Hey guys, welcome back to another video. In today's video, I'm going to be doing some last-minute Calculus BC review before the test tomorrow. These questions were provided to me by my friend, so without further ado, let's begin. So number 13 tells us that f is some function with the first derivative defined as f prime of x is equal to sine of x cubed minus 4x plus 2 from the interval 0 to 2, so the closed interval 0 to 2. And we're going to let c be the x value where f attains its minimum value, so f will probably look like this, and d will be the value where it attains its maximum value, so that's probably how it's going to look like if it's like the actual graph. So here, and then it asks us to find the difference between the x values. So to find these values, we're going to graph f prime of x and look for when it is equal to 0, because by the first derivative test, these are where critical points occur, and it has a possibility of having a minimum or a maximum. So here, if I can scroll, so here we can see the graph of the first derivative, and it can be seen that it is equal to 0 at x equals 0.539 and at x equals 1.675. So a relative minimum occurs when the derivative goes from negative to positive at a certain point. So that's relative minimum. And a relative maximum occurs when the derivative goes from positive to negative at a point. So right here, the derivative, which is this graph, goes from positive to negative, which means that our maximum occurs at x equals 0.539, or relative maximum. And right here, the derivative goes from negative to positive, which means that there's a relative minimum at this point. So we're going to take the difference between the two x values. So that'll be 1.675 minus 0.539. And looking back at our answer choices, this would be approximately 1.136. Now let's move on. Next we have a continuous function f is defined when a closed interval -4 is less than x is less than or equal to 4. The graph of the function shown in the figure to the right consists of a line and two curves. There is a value a where a is less than or equal to -4 and less than 4, for which the mean value theorem is applied to the interval a to 4 and guarantees a value c. In the interval a is less than or equal to c and c is less than 4, and which the derivative at c is equal to 3. So what are the possible values for a? So the mean value theorem only works when the graph is continuous for the whole interval and differentiable for the whole interval. So with these conditions, we're going to test out possible x values. So let's see. When a is equal to -4, we see that it's differentiable, but then over here, there's like a little jump, or not jump, but like a change in slopes, and it happens here again, which means that it is not differentiable at these 2 points, making it invalid for x equals -4 or a equals -4. And at 0, the same thing happens over here, so it can't be 2. And at 2, we start off at this point, and as you can see, it is differentiable for all points. And the average rate of change, or what the mean value theorem tells us, is that from like some interval a to b, there should be, well, if the conditions are met, there must be a secant line. There must be a tangent line that is equal to the secant line between the 2 points. And this applies here because you have a difference of 2 and a jump in, it's kind of tricky to read, but I'm pretty sure it's 6, and 6 over 2 is 3, and by the mean value theorem, there's a guaranteed value where f prime of c is equal to 3, making it that it is only number 3 only, or x a equals 2 only. Next we have number 3. It says let f be the function below where c and d are constants. If f is differentiable at x equals -1, what is the value c minus d? So the first thing I'm going to do here is take the derivative of the function. So the top half, or when x is greater than or equal to -1, will be 2x plus 2c plus 1, because whatever constant goes in front of x when x is differentiated, would just be the constant. And we do the same thing on the bottom. The derivative of e to the power of u is u prime multiplied by e to the power of u. So that's just 2e to the power of 2x plus 2 plus c. And this is from x is greater than or equal to -1. And this is from x is less than -1. So now, if it is differentiable at this point, that means when you plug in -1, these two values should be the same, or else they would have conflicting slopes. So let's test it out. For the top function, we have -2 plus 2c plus 1, and we're going to set it equal to 2e to the power of -2 plus 2, which is just e to the power of 0, which is just 1. So you have 2 plus c, and then we're going to simplify. 2c minus 1 is equal to 2 plus c, and then we subtract both sides with 1c. So now you have c minus 1 is equal to 2, and that c is equal to 3. So here we have c is equal to 3. Let's save that for later. I'm going to move a bit over here. Okay, now that we know c, we're going to set the function equal to each other, because if it's differentiable, that means it has to be continuous at this point. So we have x squared plus 2c plus 1 multiplied by x minus d is equal to e to the power of 2x plus 2 plus cx plus 3d. And this occurs at x equals -1. So now let's plug in x equals -1. -1 squared is 1 plus 2c. c is equal to 3. And 2 times 3 is 6 plus 1 is 7. So you have 7x minus d is equal to e to the power of -2 plus 2 is just e to the power of 0, which is 1, plus cx, since x is -1 and c is equal to 3, you have -3 plus 3d. And then we simplify a bit more. This should be -1, I forgot. I mean, -7. I forgot to put in the x here. So you have -6 minus d is equal to 3d minus 2. We're going to add d to both sides. So now you have 4d is equal to -6 minus 2. Now we're going to add 2 to both sides to get rid of this 2. Now you have 4d is equal to -4, and d is equal to -1. So from earlier, we're given that c equals 3 and d equals -1. So 3 minus -1 gives you 4, giving us d as our final answer. Okay, next we have number 8. It says that a particle moves in the xy plane with position given by x of t, y of t is equal to 5 minus 2t, comma, t squared minus 3 at time t. In which direction is the particle moving as it passes through the point 3, -2? So which direction is just saying what velocity does it have. So at the point 3, 2, we're going to see what time this happens at. So 5 -2t is equal to 3, because we're looking for the x value here. And solving for t, you get 2 is equal to 2t, and t equals 1. So we're going to find the velocity at t equals 1. So for parametrics or vectors, finding velocity is really easy because you just take the derivative of the position functions, and that will be -2 and 2t. So now let's plug in, let's say v of 1. That would just be x prime of 1, y prime of 1, and that would be -2 and 2. And if we draw a vector out, we get 2 units to the left and 2 units to the top. So we go up and to the left, which is A, and that is our final answer. Next, we have number 24. It says that there is a lake shaped in the form of a right triangle, and it is located next to a park as shown in the figure to the right. The depth of the lake at any point along a strip X miles away from the park's edge. So the park's edge would be here, and the strip would be like this, right? And it says strip, so that'd be a tiny change in X. So this would probably be our dx, and the depth of the lake would be f of x feet. Which of the following expressions gives the total volume of the lake? So we have this right triangle that has a hypotenuse of 5 and a side length of 5. I mean side length of 3. And by Pythagorean theorem, we know that c squared is equal to a squared plus b squared. Let's say this is our a squared. A. So we have c squared minus b squared is equal to a squared. Take the square root of both sides. C squared is 25. And b squared is 9. 25 minus 9 is 16. You take the square root, and you get that a is equal to 4. So right here, we have a triangle that has a height of 4, and we're going to take all these slices with a depth of f of x. So we're given a height, or like a width, and we're given a depth. So let's say this is, let's say width. So we're given a height and a depth, and we're going to sum up all these little areas, because the volume of any shape is just the integral of its surface area. So if we take up all these little slices from the side, we will get our final volume. But first, we need to know what our height function is. So since we start at 4 and we go down to 0 after 3 units, right? We're going to have a function that is based on, let's see, I'm going to make it based on point slope form. So right here we have, let's say this point over here. Y minus 4 is equal to slope x minus 0. So this is the point slope form at x equals 0 or 0, 4. And we need to find our slope. So we have a change in height. A change in y is negative 4. And our change in x is 3. So our slope will be negative 4 over 3. And if we solve for y on its own, we have negative 4 over 3x plus 4, or 4 minus 4 over 3x, which looks like the value inside of this integral. And since this doesn't line up with any of the answer choices, you can safely choose A. Another way of finding this out is that once you know the height function, you know that every single slice will have a depth of f of x. So if you take the sum of all those f of x's, you will eventually get the area. Volume. And now we are on to our final problem. Here, for number 12, it says that the derivative of a function f is defined by f prime of x is equal to g of x for when x is equal to when x is less than or equal to 1 or less, when negative 1 is less than or equal to x and x is less than or equal to 3. So this is g of x right here. Negative 1. This is g of x. And 1, and it is equal to 1 minus 2 e to the power of x plus 1 when x is greater than or equal to negative 3 and less than negative 1. So this is the second function, or second piecewise component of it. So now, based on the graph, which of the following statements are true? Let's see. 1 says that f has a relative maximum at x equals negative 1 minus natural log of 2. Over here, it seems to be around this point, and at this point, the derivative seems to be going from positive to negative, and by the first derivative test, whenever a derivative of a function changes signs from positive to negative, so when it goes from increasing to decreasing, there is a relative maximum at that point. And to make sure that it's actually at x equals negative 1 minus natural log of 2, I'm going to set this component of the derivative equal to 0. So we're going to solve for x when this is equal to 0. Let's see. Now we have 1/2 is equal to e to the power of x plus 1. Take the natural log of both sides. You have x plus 1 is equal to natural log 1/2. And here we're going to subtract 1 from both sides. You have natural log of 1/2 minus 1. Natural log of 1/2 is equal to the natural log of 2 to the power of negative 1. So that would be negative 1 natural log of 2. And plugging that back in, you have x is equal to negative natural log of 2 minus 1. Or if you put the negative 1 in front, you get the same x value for number 1. So this is true. Let's see. Number 2 says that f has an inflection point at x equals 1. X equals 1 is right here. And as you can see, the derivative goes from decreasing to increasing at this point. So similar to the first derivative test, you can apply it again to this derivative, and then you can tell that there's an inflection point, because an inflection point is whenever the second derivative changes signs or when, for here, the second derivative goes from negative to positive, and that's true for this point, so number 2 is true as well. Number 3 says that f is increasing from 1 to 3. That is not true, because the derivative or the rate of change of the original function is less than 0, meaning that it's actually decreasing. So you eliminate D and A and B, leaving us with C, and that is our final answer. Thank you for watching today's video. I hope you enjoyed, and let's all get 5s tomorrow. Woohoo! We are AP Calculus BC!